Ah, there we go, all nice and freshly shaven. We're up to question number 4 on the 2011 Galois paper. So hopefully you've had a chance to take a look at it. Again, the link is in the description. You can go to the CMC website, get past contests, get this one. You can get their solutions to this one. You can try other Galois or other years. Fridays are easier, Hypatias are harder. Okay? So, what does question 4 have to offer? For a positive integer n, the nth triangular number is Tn, equals n times n plus 1 over 2. For example, T3 is 3 times 3 plus 1 over 2, 3 times 4 over 2, so 6. The third triangular number is 6. Now they're called triangular numbers, just in case you've never seen this before. They're called triangular numbers because what we do is we make triangles out of them. So our first triangular number is just a dot, it's 1. How many dots in the next triangle is 3. And then the third one, which is what they're talking about, is 6 dots make a triangle. The next one after that will be 10. So we'll have 4 rows of dots. So this is why we call them triangular numbers. Then the general formula for the nth triangular number is n times n plus 1 all over 2. Okay. So we're introduced to the formula and the nomenclature, triangular number. Okay, fine. We have 4 parts here, A, B, C, and D. A. There is one positive integer A, so that the 4th triangular number plus the 8th triangular number is equal to the 10th triangular number, determine A. Okay, well, we have a formula for the 8th triangular number, and the 4th one, and the 10th one, so why don't we just work them out? So T4 plus TA is equal to T10. So that's 4 times 4 plus 1 all over 2 plus A times A plus 1 all over 2. And we can see why they had to specify a positive solution. I suspect we're going to get a quadratic in A. And then we'll have to solve it. One of them will be positive, one of them will be negative. So this is 4 times 5 over 2, so that's 20 over 2, which is 10. 10 plus A times A plus 1 over 2. And 10 times 11, so that's 110 over 2 is 55. So A times A plus 1 over 2, that's going to be 55. Minus 10, that's 45. So as I say, I'm going to want to get a quadratic out of this. I'm going to multiply both sides by 2. Just because I don't like fractions. So A times A plus 1 is 90. And at this point, we could probably guess, well, what's a number times the number plus 1 equals 90? I'd guess 9, because 9 times 10 is equal to 90. But let's actually work it out. Put our quadratic formulas to skills to work. So A squared plus A minus 90 equals 0. Again, you could factor it at this point, or you could quadratic formula. So negative 1 plus or minus square root of 1 squared minus 4 negative 90 all over 2. Negative 1 plus or minus, this will be 361, which is 19 squared. So negative 1 plus or minus 19 all over 2. And we'll get answers of 9 or negative 10. So 9 is our answer. Okay. So we have the 9 and we have the necessary steps explaining why we have A is equal to 9. Okay. B part. Determine the smallest integer B greater than 2011, another instance of the year of the contest jumping up, so that B plus 1 minus TB, so the B plus first triangular number minus the Bth triangular number, is equal to the X triangular number for some positive integer X. Well, let's set up an equation. We don't quite know what X is, but we're going to have a bunch of stuff in B here. And there's probably going to be lots of situations where this works. So it might work out that x has always got to be a multiple of 3, so b will always have to be a multiple of 4 plus 1 or something like that. So we just take the smallest multiple of 4 plus 1 that is bigger than 2011. That sort of thing is what's going to go on here. So b plus 1 times b plus 1, which is 2, b plus 2, all over 2 minus b times b plus 1 all over 2 is equal to x times x plus 1 all over 2. Just as I did before, I'm going to multiply through by 2 and get rid of all the instances of 2 here. I'm also going to take out a factor of b plus 1 on this side. Okay. Well, b plus 1 minus b, those guys, these b's here cancel out. So we're going to be left with b plus 1 times 2 is x times x plus 1. So just something I'm noticing right away, b plus 1, if I divide both sides by 2, b plus 1 has got to be tx. So we want a triangular number, and we want b to be greater than 2011. So we're basically looking for the xth triangular number, and we want the smallest one that's bigger than 2012. Okay. Okay, so what can we do here? Well, we could always guess and check because we have the formula. But tx is a quadratic equation. We can expand them out and it looks like this. So as a graph, this is a parabola that is always increasing. So over here, not at 2012, over here, so we have 2012 over here, we have b plus 1 over here. We're going to, there's a parabola, that is always increasing. So b plus 1 is got to be greater than 2012, and it's got to correspond to an integer. So the smallest that b plus 1 can be, if x is the next integer, after the solution to 2012 equals this equation here, which we probably shouldn't use x again, we should use, I don't know, y. Okay, so now we have a plan of attack. If we can figure out where this quadratic is equal to 2012, and that'll give us some value here on the independent axis, we figure out the next integer, because we know x has got to be a positive integer, then we should be all set. Okay? So, let's solve half y squared plus 1 half y is equal to 2012. And it might be, I mean, I haven't worked it out yet, but it might be that y is an integer, in which case that y will be the integer x that we're looking at. So let's multiply by 2. So we get y squared plus y is equal to 4024. So y squared plus y minus 4024 equals 0. Bring on the quadratic formula. Y is negative 1 plus or minus square root of 1 squared minus 4ac all over 2. Negative 1 plus or minus the square root of, so what's inside here? 4 times 4024 plus 1 16,097. So if we square root that, 16,097, we basically get 126.8. I'm going to use the plus version, because otherwise we're going to get a negative number. So I subtract 1 from the 126.87, etc. I get 125.87, and then when I divide by 2, I get about 62.93. So what we're going to do is we're going to let x equal 63. So that's the next integer over. So let's just double check. So tx, which we need to figure out anyway, but let's just make sure it's a number that's really close to 2012. So 63 times 64 all over 2. $2,016. So that's really close. That's basically as close as we're going to get. And we want b is t of 63 minus 1. So b is going to be 2015. Okay. So smallest integer b, so that this all works out. And what we could do if we really wanted to double check, what we could do is we could say, okay, b is going to be 2015. Let's make sure we got it all right by figuring out t of b plus 1, so t of 2016, and t of 2015. Subtract them and see, do we really get the t of 63 that we desire. And I'm just going to quickly do that on a calculator, just to verify. On a real contest, you'd have to judge, do I have enough time to do this or not? So I want 2016 times 2017, all divided by 2. So that's t of 2016. And now we want minus 2015 times 2016 divided by 2. And what do you know? I get 2016, which again was t of 63. So it looks like we have the right answer. Well, another thing we could do to double check would be take the next lowest integer b and see whether or not it works. In fact, since we think b is 2015, we could try 2014, 2013, 2012, and make sure that those numbers definitely don't also give us a triangular number out. It'd be extra work. I'm not going to do it right here. I don't recommend you do it on a contest because time is precious. We only get so much time for these contests. But, you know, if you say C and D are lost causes, you find you have 10 minutes, why not go through and make sure that all the other smaller possible values of B don't work. They don't give Tx another triangular number. Okay? Just food for thought there. So let's figure out C here. So if Tc, so the cth triangular number plus the dth triangular number is equal to the eth triangular number, and we know c plus d plus e is t of 28, show that cd is equal to 407 times c plus d minus 203. Okay. Now I noticed that 407 is almost twice 203. That's just something that jumped out at me right away. I wonder what t of 28 is. So let's actually work this out. We're going to write down these equations here. So first we'll just box our answer to the last one. So I know t of c plus t of d is equal to t of e. So that's c times c plus 1 over 2 plus d times d plus 1 over 2 is equal to e times e plus 1 all over 2. And since I have been taking out the division by 2 each time by multiplying the equations by 2, I figure I'll just jump ahead and do that. Anyway, I don't know if I'll need it. But I find this second equation much nicer to look at than all these division by 2's. So that was the first thing we noticed, we were told, and we also know that c plus d plus e is t of 28. Now that's a very specific value. Let's work it out. 28 times 28 plus 1 over 2. Well, that's 28 times 29, all divided by 2. That's 406. And we were asked about 407 and 203. Okay. So, are we given any other information here? We know their sum is t28. Show that CD is 407, c plus d minus 203. Okay. Alright, so one thing I can do is I can rearrange this second equation here and get c plus d, which is part of what I need, in terms of, actually no, I can get e in terms of a constant number and c plus d. Then I can plug that back in here and maybe I can work something out. So let's solve for e. E is going to be 406 minus, I'm going to group them together as c plus d rather than minus c minus d. I'm going to call this equation, we'll have equation 1, we'll have equation 1 prime, and this is equation 2, so we'll call this equation 2 prime. Alright. So we're going to sub into equation 1 prime. So c times c plus 1, d times d plus 1 is equal to 406 minus c plus d times, oh, here comes 407. I'm going to write this on another line. (406 minus c plus d) times 406 minus c plus d plus 1. Well, we can group the constants and say 407 minus c plus d. Alrighty. Actually, we should probably just sub this into 1. Should we? No. We'll deal with that in a moment. So, I'm seeing I got my 407 here. I've got, what else do I need? I have 407 here. I have a c plus d minus 203. So we're sort of in the ballpark. We've got a 407 kicking around. And we have 406, which is twice 203. So I think I should probably expand this out. So we're going to say 407, 403 minus c plus d minus c plus d, 406 minus C plus D. So I'm liking the first term here. I don't want to mess with it right now. I have a feeling I'll divide by 2 at some point. This second term here, I think I'm going to expand it out. And I'm also going to expand the C times C plus 1 and D times D plus 1 on the other side. So C squared plus C plus D squared plus D is equal to 407, 406 minus C plus D plus, and now it was C plus D times 406 minus, the whole thing was minus. So this one will become plus C plus D squared, so that's C squared plus 2CD plus D squared. Aha, there's my CD, so that's great. My C squareds on either side are going to cancel out. My D squareds on either side are going to cancel out. So there's the 2 that I'm probably going to divide by. Okay. So I've got a C plus D on this side. 407, 406 minus C plus D. Minus 406 C plus D. I'm probably going to want to group my C plus D. You know what? Actually, I should expand the whole thing. Get all my C plus Ds together. All my ducks in a row. So 407 times 406. It's 165242. I'm going to put this C plus D in brackets. Minus 407 C plus D. Minus 406 C plus D. So I'll group all my C plus Ds together. Plus 2CD. So we want CD all on its own. So we're going to bring it over to one side. So 2CD is equal to, well, we have 1 CD by itself, and then we have to add on 407 CDs. Then add on 406 CDs. And subtract off 165242. Alright. Well, we can simplify this. So this is 1 CD, this is 406 CDs, so we're going to have 407 CDs plus 407 CDs, so we're going to have 814 copies of C plus D minus 165242. And if I divide both sides by 2, I'll be left with CD is equal to 407 C plus D, and then what's 165242 divided by 2? 621. And I'm betting that factors as 203 times 407. It does, so let's take out that factor of 407. C plus D minus 203. Little statement there showing that we have shown exactly what we're asked to show. We just go back and double check that that is exactly what we wanted to show. Okay. So now D. Determine all triples C, D, E of positive integers such that TC plus TD is equal to TE. And C plus D plus E is T28. And we have the added condition. So it's the two conditions we had in the last part. But we also have C less than or equal to D, less than or equal to D. We also have positive integers, which weren't mentioned in the last part as well. Okay. Well, I know if I have TC plus TD plus TE and C plus D plus E is T28 that I'll get this condition. If I have this condition, do I necessarily have that these ones are true? Because then I could just find C's and D's that solve this. And that should get me home free, I think. Actually, I could probably use this to solve for D in terms of C, and that would definitely help. Could I solve for D in terms of C? Well, let's find out. So we know CD is 407 times C plus D over 2003, or minus 2003. So if we expand this out a little bit, we get 8261. Let's collect all our D's onto one side. So C minus 407 times D is equal to 407C minus 82621. So if I want D by itself, that's 407C. I can take a C out of here, and we'll be left with minus 203, and it'll be over C minus 407. Okay, so this is D in terms of C. And we know C, we don't know C. C is just a given variable. We know D in terms of C, and we also know E in terms of C and D. And so we can probably work out E in terms of C. But I know D has to be an integer. So that sort of limits what C can be. 407, just out of curiosity, is that a prime number? So the square root of 407 is about 20, so I'll just divide 407. Does that divide by 11? Yeah, it does. It's 37. Okay, 37 by 11. What to do. So that D, I know that E is T28 minus C minus D. Is there any point in putting this all in terms of C? Well, let's find out. That's 406 minus C minus 407 C minus 203 over C minus 407. Well, let's get a common denominator here. 406C minus, what's 406 times 407? 165242 minus C squared plus 407C minus, I need more space, (406C minus 165,242 minus C squared plus 407C minus 407C minus 203 times 407, which I keep forgetting. (82621). all over c minus 407. So there's some cleaning up to do here. These two cancel out. These two cancel out and leave 82621. Or not those two, these two. My mistake. So we'll be left with 406c minus c squared plus 82621 all over c minus 407. I want this to have a factor of c minus 407. I don't know if it does. So let's just try it. What would we need to say here? So we need 407 squared minus 406 times 407 minus 82621. 407 times 407, well, this is just going to be a 407 right here. Minus 82621, so no. So we can clear that page. So that's not going to be a root. But we do have a handy equation for E. E is going to be 82621 plus 406c minus c squared all over c minus 407. And that also has to be an integer. Okay. So where can we go from here? So I want C less than D less than E. I feel like focusing on the relationship between C and D is going to be the best, and then the E's we'll just calculate at the end and see whether or not they actually work out. I was hoping that C minus 407 would be a factor of this quadratic up here. That way E would always be an integer no matter what C is. But looks like we're not going to have that. So if only we had, actually we do have an upper bound. We know that C has got to be greater than or equal to 408, and he's got to be less than or equal to 814, right? Because 814 was T of 28. Oh, no, sorry, 406. Wait a minute, what? Oh, this could be negative. Okay, never mind. So C has got to be between 1 and 406. Okay, so that means the C's got to be positive, and 406 was T28. Right, since C, D, and E are all positive, in fact, we could probably say he's got to be less than 306 divided by 3, or sorry, 406 divided by 3, but I don't think we need to say that right now. No, let's say that right now. It might help us out. So I know C plus D plus E is T of 28, which, as we keep pointing out, is 406. So 3c is going to be less than c plus d plus e, which is 406. So c is going to be less than or equal to 135 and a third. So c has got to be a positive integer between 1 and 135 inclusive. So now we have a range of values for c. What I'm going to do is I'm going to see which of them give, I'm going to take c minus 407, because that's what I need to divide by in order to get d. That's in our formula for d. I'm going to see which of these, I'm going to compute c minus 407, and I should probably also deal with c minus 203, and see if I get any of the factors I'm looking for. Because 407 is 37 times 11, so hope the division all works out. But well, let's see what range of values we get for c minus 407. All right. Oops, wrong thing. So negative 406 is less than c minus 407, and then 135 minus 407, negative 272. So we want c minus 407 to be in this range and give us a nice value for d. So the problem here is that c minus 203. I feel like these guys should have no factors in common. In which case we need c minus 407 to have factors in common with 407. That's the thinking here. I don't know, I feel like this is taking too long. Just sort of like the last one with the question 3 with that Pythagorean solution. So let's go back and take a look at, we figured out the formula in C part. Wondering if this formula CD is equal to 407 times C plus D minus 203. Maybe that is more important. The problem is I have two variables here, C and D, that vary. I don't like that. I don't like that one bit. What to do, what to do, what to do. Well, 407 I know is 37 times 11. So if CD is equal to 407 times C plus D minus 203, one of these has got to have the 11, one of these has got to have the 37. And that would probably help in some way. Alright, I'm going to refocus my efforts. I'll put this on hold. I'll write a little bit on hold. This might be a dead end. It seems like I'm doing too much work. I want to get back to the original task at hand. So I'm putting that on hold for a moment. I'm just going to take a look at this formula. CD equals 407 C plus D minus 2 over 3. Because I feel like I'm doing too much work. It's a Galois 4, which does require work, but it seems like I'm doing too much work. So these guys are positive integers. So C plus D minus 203 must also be a positive integer. Otherwise, we'd have a negative times a positive, and that wouldn't be equal to a positive times a positive. And it's got to be an integer because we have integer plus integer minus integer. Now, 407 is 11 times 37. We worked that out a little while ago. So 11 divides CD. Well, actually, no. The point is 407 divides CD. So either 11 divides C, 37 divides D, 37 divides C, 11 divides D, or 407 divides C, or 407 divides D. Now we can't have either of these. Because C plus D plus E is 407. So C and D must be less than or equal to 407, which is definitely less than 407. So 407 does not divide C. And 407 does not divide D. So one of these has to have the 11, the other one has to have the 37. Okay. Now, I don't know if this is the right thing to do, but I'm going to say let C be 11P and D be 37Q. P and Q are going to have to be positive integers. Okay. So, what has that really gained us? So 11P 37Q is 407 times 11P plus 37Q minus 203. So PQ is 11P plus 37Q minus 203. So it looks like we've traded one equation for another. I'll tell you what I'll do. We won't use this, because we have really just traded one equation for another. What we'll do is we'll do two cases. We'll say, well, let's let C be so case 1, 11 divides C, 37 divides D. Now we know that 1 is less than or equal to C is less than or equal to 135. So what are the multiples of 11 in here? Well, there's 11, 22, 33, 44, 55, 66, 77, 88, 99, 110, and 121, and 132. So those are the only possible C values we could have. Now as for D, well, we could plug each of these C values in and get a quadratic formula. Or we could use our equation of D in terms of C. That's C minus 203 over C minus 407. We could plug each of these C's in here and see what happens. So for example, if I plug in 11 minus 203 is negative 192, divided by 11 minus 407, multiplied by 407, I get 197.3. Repeating, that one's not going to work. So this is what I'm going to do. I'm going to make a column, my C's, my D, which is 407, C minus 203, C minus 407. And if I get an integer for C and an integer for D, then I'll definitely get an integer for E. So 11, 22, 33, 44, 55, 66, 77, 88, 99, 110, 121, and 132. Okay. So this was already 197 and 1/3. What happens if I plug in 22? Well, 22 minus 203 is negative 181, divided by 22 over 407, multiplied by 407. We get 191.34 something or other. So that's no good. 33 minus 203, that's 170. Divided by 33 minus 407. That's 0.454545 times 407. That's 185. Okay. So I'm liking that. I wonder if the next multiple of 3 will also work out. 185. And if so, there might be some sort of critical property that I'm missing ever so slightly. Well, actually, C is 11p. Let's just say that. So D is 407, 11 minus 203, or 11p minus 203, all over 11p minus 407. And 11 will come out of here and here. So it should be p minus 37. P minus 37. That's what we want to have. So 44 minus 203 divided by 4 minus 77. And then when we multiply through by 37, we get 178.27. That's not going to work. How about 55 minus 203 divided by 55 minus 407. And we multiply through. There we get 171.125. Now 66, this one might actually do something. So 66 minus 203 divided by 66 minus 407 multiplied by 407. Nope, 163.516. Okay. So 77 minus 203. This seems like it's taking way too long. Uh, 155.4. 37 and 203, they don't relate to each other, do they? No, they do not. And 203, of course, not a multiple of 11. Very curious. Alright. Well, I'm just going to keep plugging away. Sometimes that's what you have to do until you have an epiphany. $156.72, that's also not going to work. I wonder if there's only one. Don't have the wherewithal to defend that assumption, but now we're on to 99. Got 137.42. That's not going to work. $127.44. That's also not going to work. Oh, 121 minus 203. And I'm getting 116.69. And the last one, I don't think this will work. Nope, 105.08. So really, we just had this one here that worked. But I didn't like that lengthy calculation one bit. I want to see if there was a better way to realize this. So obviously if we say C is 11p, a whole bunch of stuff cancels out. We're left with this slightly simpler looking thing. So we really just want to ask ourselves, when does p minus 37 divide 11p minus 203? For some reason the answer is p equals 3. But why? Well, what if I use polynomial division on it? So I have 11p minus 203. And I use polynomial division. So I should get an 11 here, and then 11p minus 407 here. Get 0. This should be 204. So using polynomial division, I can see that 11p minus 203 is going to be 11 plus 2 over 4 p minus 37. So what are the factors of 204? 3. Yeah, I like this. I like this a lot better. Okay. So I'm going to explain what I'm doing here, because now that I've finally caught wind of it. So we don't need this chart, although we did spend a lot of time looking at it. So let's see, 11p, p is positive integer. Okay. From our previous work, we know d is 407, c minus 203, all over c minus 407. Well, if we plug in the 11p in there, we'll see that d is 37, 11p minus 203, all over p minus 37. So d is an integer if 11p minus 203 p minus 37 is. Okay. So I see this 11p and I see this p. They're both linear terms. I suspect that this one's basically going to be p times 11, or 11 times p minus 37. So let's see how far off they are. 11p minus 407, not a big surprise there. But we basically want that to be similar to 11p minus 203. So okay. Sorry. So 11 times p minus 37 is 11p minus 407. Now, how far off of the one we want is that? Well, it's the 11p's are going to cancel out, and it's negative 407 minus 203, so that's going to be negative 204. Okay. So if I rearrange this, I can say that the one that I want, which is 11p minus 204, is 11 times p minus 37 plus 204. Now, I don't want 11p minus 203 by itself. I want 11p minus 203 minus over p minus 37. That's going to be 11 plus this thing over here. And that's an integer if this weird fraction-y term is an int. So we need p minus 37 to divide 204. Well, what's 204? It's 2 squared times 3 times 17. So I must have a factor of 204. But we also know that 1 is less than c is less than 1035. And that tells us that p is going to be between 12 and 1. So we need p to be between 1 and 12, and we need p minus 37 to be a factor of 204. So p minus 37 could be negative 36, negative 35, negative 34, negative 33, negative 32, and so on. Negative 31, negative 30, negative 29, negative 28, and we're going to have to stop in a moment, negative 27, negative 26, and negative 25. So those are the possibilities, but of these possibilities, only this one is a factor. Only negative 34 divides 204. Okay. So that's how we can narrow it down. We don't have to do that lengthy calculation that I was doing on the calculator every single time. Only negative 34 is going to do it. Or negative 34. So now, so P is 3, C is 33, D was, what's the value for D? It's 11 times P minus 203 divided by P minus 33 or 37 times 37, so 185. And E is going to be 406 minus C minus D. $188. So 33, 185, and 188 is a solution. And that's what happens when we said let C be a multiple of 11. Now, we also had the other possibility, let C be a multiple of 37. So that's C is divisible by 37, and 11 is divisible by D. Okay? So now, armed with our new technique, let's let C be 37Q. D is 407 minus C times C minus 203 all over C minus 407. Let's substitute in our 37Q. So we'll be able to take out a factor of 37 here, here, and here. Left with an 11 up top. So it's 11 times 37Q minus 203 all over Q minus 11. Okay. So 37 times Q minus 11 is 37Q minus 407. Giving us another difference of 204. So what we want is 37Q minus 203 over Q minus 11 to be an integer. So that's 37 over 204 minus Q, or over Q minus 11. And once again, C is between 1 and 135. So Q is going to be between 1 and 3. So that means that negative 10 is less than Q minus 11. It's less than negative 8. And none of these are factors of 204. So none of them are factors of 204. That's okay. That means no C values. I mean, there's certainly potential C values, but none of them give integer values for D. So there are no solutions. So really, the only solution we could have, because we've done both our cases, is at long last CD is 33, 185, and 188. And if we wanted to, we could check and make sure. Well, we know that these guys add up to the desired amount, which is 406, which once again is T28. But let's just sort of double check. Does the 33rd triangular number, which is 561, and the 185th triangular number, what's that? Well, that's 17205. And the 188th triangular number, this should be the sum of both of them. $17766. And it is. Okay, so this was our little check. So we got them all. Well, we got them all. There was only one. So that does it for the 2011 Galois. I must say those last two questions, I certainly thought I had the right method, but it turns out I was doing way too much calculation. And that's something that you guys should learn for when you do the competitions as you're practicing. If you find you are doing way too much calculations, or if you've lost sight of your original goals, stop and think and go back. These questions are designed to be sort of very nicely solved. So for that last one, D, I realized I was getting really, really far away from my goal, which was figuring out C, D, and E. I would have had a giant table if I'd kept going. I wouldn't have liked that at all. And more importantly, I was getting away from the thing that I proved in C part. Now, the thing we proved in C part, because it's C, it should be helping us in D. That's usually how these questions are structured. A, and to a lesser extent B, will get us familiar with the concept being introduced. B and oftentimes C will give us a nice, healthy result. And D, we will often use that result to show some other really big or interesting thing or enumerate a list like we did in this case. So I put the one technique on hold. I said I'm going to go back, I'm going to re-examine my CD equals 407 times C plus D minus 203. And when I stopped and I re-examined that, I came up with a better way of doing the question that still incorporated some of the work I had done. That formula for D, all in terms of C, I liked using that. Yeah, overall, you have to be aware of whether or not you're going down the wrong path or whether or not you're missing something because you're just taking too long with your calculations. You'll also see I didn't like filling out that little table with the 11, the 22, the 33. I was just punching away on my calculator, and that shouldn't be how you do these questions. So I said, well, okay, I'll finish the little table, I'll get my answer, and then I'll see, was there a smarter way to do this? And there was, using sort of polynomial division or just finding factors of 204. I'd be very interested to see what their solution method is, and of course, you can click the link in the description. It takes you to all their past contests and past solutions. So if you don't like my solution for 4, go take a look at theirs. It's probably a little neater because they've had time to think about it, whereas I just try and do these questions the way you guys might try and do them on a contest. And sometimes I go wildly over time, and that's not good. Time management is important for these contests. But I could keep prattling on about what's important for contests and what there is to know. But I think this video is already pretty long. Let's just end it there. So that was the 2011 Galois. Some interesting questions, some challenging questions, and certainly some wrong turns taken by me. But hopefully you guys did better. So, yeah, not a whole lot else to say. The 2012 Galois should be coming up in a little while, or the 2011 Hypatia is probably the next thing I'm going to post. So stay tuned for those, and I'll see you guys in the next video. Thank you so much for watching.